Hello again, everybody. So today we start talking about objects and classes. Now that we're done with some of the revisions of our arrays, um, so I know you've worked with objects or have been introduced to objects and classes in Programming 1. Um, so uh, a class is basically uh, used in object-oriented programming languages like Java, is basically used to describe things such as an event, things, uh, physical things, other kinds of things, concepts, um, roles, organizations, units, places, and structures. So can really represent a lot of things. Um, but the thing to remember is that objects are, basically have they have their own identity, usually their name. They have a state uh, and behaviors. Now I'll talk a little bit more about, I'll explain a little bit more about what we mean by state of an object or behavior of an object. So in the context of programming, the state of an object refers to the data that it is that object contains. The behavior of an object refers basically to all the methods that are contained within or that an object can execute. So, in other words, an object is a bundle of software. It's a software bundle that contains variables and contains methods that work with those variables, that are related to those variables. Um, to clarify this a little further, there's a slide in the lectures set that I uploaded. Um, and let's say you could use classes and objects and to model an occurrence, an event. So, for example, an example of a class that models type of occurrence is an alarm, and an example object of an alarm is a fire alarm. Perhaps more easy to understand, to grasp, is let's say we want to use classes and objects to model physical objects, physical things. So, for example, we could have a class called car, and that car class could then be used to model or represent an object, a specific car, such as a Ferrari 360. Um, Similarly, you could have a class called door, which could, an example of which would be a fire door. You could use a class to classes and objects to represent roles, such as the role of a teacher. Teacher could be a class, and an example object of a teacher could be a specific teacher, such as Mr. Muhammad Hassan. Okay. You can use classes and objects to represent organizational units, such as you could have a class, a department class, and example objects that can be represented by a department class would be the CS department, the IT department, the IS department that we have here at FCIT. So, sorry, oops, okay. So, it, simplifying a little bit, you can map real world objects such as a bicycle, a teacher, a book. You can map those to, um, to classes or objects in a program, and then you can have methods attached or included, I should say, in those classes to interact with those objects, to have those objects interact. Um, Now, there's actually a standardized way by which we can represent a single class, or actually even a group of objects or classes using something called a UML class and object diagram. Uh, this is basically this box this tabular box that you can see over here. Here's a description of what a UML class diagram looks like, and we'll be seeing a lot more UML class diagrams. As a matter of fact, once you understand what these represent, instead of giving you a textual description of what type of class I want you to create, I will just be giving you diagrams like this that will basically explain a lot of the properties that a class that I want you to write that should have. So here at the top we have a UML class diagram. At the bottom over here, this is a similar UML notation for objects. So specific instances, or I should say examples of this class above. So first of all, a UML class diagram is made up of three boxes or three compartments. The one at the top contains the name of the class. So over here, this class over here is a class called student. The second box, the second compartment, contains all the data elements, all the variables that are contained in this class. So in this case, it's a very simple class. It contains one variable called name, the first thing over here. And after the colon, we also specify the data type of that variable. So in this case, name is a variable of type string. And in the third compartment, the third box down here, we put all the names of all the methods that are included in this class, in this student class. So in this example, we have two methods, one called getName and one called setName. You can see one of these methods has a colon, and after which it says string. This is the return type of this method. So this is the type of this is basically the type that this method is returning. This method getName is returning a string. It does something and gives us back a string. Now here at the bottom, this is a UML notation for three objects, and you can see that these the names of these objects are S1, S2, and S3, and after the colon in the top box says student for all three of them. These are basically three objects of class student, or three instances, three examples of class student. And in the second box, we specify the value that all the variables of this class have. So class student has variable name of type string. So this object S1 is one in which the value of its member variable, member variable name is Ahmed. In object S2, the value of the member variable name is Ali, and in the third one it is Sohail. So this might seem, this whole figure stuff, this UML diagram, these UML diagrams may seem a little abstract to you. So here's a more general description of how we structure the code for a class. So usually any libraries that you have to import go at the top. Any comments go right after that. We've already seen that. And then we write class, the name of the class, and we open parentheses, and we close them at the bottom, and in between go first. We usually write all the data elements that go into this class, followed by all the methods, including a special type of methods called constructors. All of those go inside these parentheses. Okay, so let me switch over to a new project called, I'm calling this one week 4.2. And when you create a new project, you basically get just this one source file. Now, remember in Java, all these files that we write, all these .java files that we write, um, each each source file with extension .java may contain only one class. Now, what I'm going to do here is I want to create this class student, and I want to use it. I'll use it inside the main method of this class week 4 or week underscore 4 week 4.2. I'm just going to call this week 4.2. But I have to add a new file to this project week 4.2. So what I do is I go into source packages of this project. A package is basically a collection of classes that somehow that belong together. We'll talk more about packages a little later in the course. So if I want to add a new class to my project, right click on the package and I want to add a new Java class. Select that and now it will ask me what the name of that class is going to be. In our case, the name of the class is going to be student. Finish. And there you go. And see, we have a new file called student.java. And you know, the name of the source file containing the course for a new the code for a new class has to be the same as the name of the class. So if the class name is student, the name of the file has to be student.java. Okay. Let me also show you something else if you're wondering what these things are for. So this is basically, you can roll up basically all these comments. Nothing of interest in there anyway. So as you can see, I have specified which package this class is going to belong to, and I can now start writing the code for this new class student. And I'm going to keep it very simple. As you saw, class student contains a single variable, single member variable we say, called name of type string. And it contained two methods. The first one was called getName and returned a string. So I write string getName, and it did not take any argument. And what this method, typically methods that begin with the name get and are followed by the name of the name of any member variable, like it does over here. Get name, name is a member variable. These methods typically give access to, or simply return the value of that variable. So in this case, something very simple. It's just going to return the name variable. Just going to read that and give that back. That's it. And then we also have a bunch of, usually very often we have these methods that start with the word set, like set name, the one that we have here. These methods are usually used to assign a new value to a member variable, usually the one that's being named over here. So set name is going to take the string provided in the argument of method set name, and it is going to assign it to member variable name. That's it. And this method is not returning anything, so return type for set name is void, which is the same as null or nothing. That's it. That's our very first uh, simple new class. Now, obviously, you can see that there's no main method in here. That main method has to be is in here, in this original file. Now, we want to make use of the student class. Let's save this very quickly. So let me write something very simple over here. Student S1, like the one we had in the example, and this is going to declare an object named S1 of type student, but it's not going to create that object. So to create it, I have to do something that should look familiar to you. I do this. And guess what? Just like in arrays, instead of doing this in 2 steps, so declare object and typo. Instead of doing the declaration and creation in 2 steps, I could also do this in 1 step, and probably guess what that looks like. Yep, like this. So actually let me make 2 different objects. First one is created in 2 steps, second one is created in 1 step. And we also create a third object, S3, as we saw in that UML object diagram. So now we have created 3 objects. Let me run this. There you go, no problems. Obviously we haven't done anything with these objects yet. So let me use switch back quickly. So student S1's name is Ahmed, S2's name is Ali, and S3's name is Sohail, right? Ahmed, Ali, and Sohail. So let's just do this. S1 dot set name, and S1's name is supposed to be Ahmed. S2's, as you can see, the IDE is giving us some level of auto-completion here because it understands, knows which class I'm talking about. So S3 is an object of type name. It knows that. Set name, the method is being recognized. Oh, there you go. So here. Okay. So I can run this and it should work, no problems. Now, just to check just to check that these strings were actually assigned to the name variable of these objects. Let's just print them out using the getName method. So system out dot and we have s1 dot name is equal to s1 dot getName. So s1 dot getName will read the value of the name member variable of s1 and attach it or concatenate it to this neat looking string over here. I'm going to do the same thing for the other 2 objects, S2 and S3. And let's see what we get. There you go. S1.name is indeed Ahmed. S2's name variable contains indeed Ali and S3 is